Section 1.8 Absolute Value Equations and Inequalities. Absolute value of a number a gives the distance from a to 0 on a number 9. So look at this example. When I have the equation absolute value of x equal to 3, you could think about it. All the real numbers at a distance of 3 units from 0. So this is a positive 3 or negative 3. This is the meaning of absolute value of x equal to 3. It can be positive 3 or negative 3. So the solution set of this equation would be negative 3 or 3. And for each equation or inequality, in case 1, 2, 3 in the table, assume that k greater than 0. Case 1. When I have absolute value of x equal to k is a positive value. Then that means x equal to positive k or x equal to negative k. Just like the previous example, absolute value of x equal to 3. So x, it can be equal to negative 3 or positive 3. So when I graph of the solution set, I'm gonna have a dot to the negative k or k here. So this is gonna be my solution set. Case 2, when you have an absolute value of x strictly less than k. Okay, strictly less than. So you could rewrite it x that would be in between negative k to positive k. And keep in mind, your absolute value of x is always on your left-hand side. So that's a strictly less than k, okay? So since there's a no equal sign here, we will use the parenthesis. X is in between negative k to k. And then the solution set will be parenthesis negative k to k here. Case 3, when you have the absolute value of x strictly greater than k, okay, greater than k. So that will be this joint solution. X is strictly less than negative k or x strictly greater than k. Okay, you're gonna see this is a disjoint solution. This is how you guys graph of the solution set when it's a case 3 here. And then we're gonna write down the solution set parenthesis from negative infinity to negative k parenthesis, or the union means or. Parenthesis k and then until positive infinity. I need you guys remember this table. Okay, highlight it. You have to remember that when you have the case 2, absolute value of x strictly less than k, then the solution will be x in between negative k to k. When absolute value of x greater than k, okay, strictly greater than k, then you're gonna have the disjoint solution here. Additionally, if an absolute value equation takes the form absolute value of a equal to absolute value of b, then a and b must equal in value or opposite in value. So either both of them are positive, a equal to b, or you should have one of them is going to be negative, a equal to negative b. Okay, let's try to do example 1. I have an absolute value of 9 minus 4x equals 7. So go back to this table. That will be on your case 1, right? Absolute value of x equal to k. So that will be equivalent to x equal to k or x equal to negative k. So do the same thing. 9 minus 4x, that will be equal to positive 7 or negative 7. And then we're gonna isolate the variable of x. So we're gonna subtract 9 for both sides. Subtract 9 here, subtract 9 here. I'm gonna get negative 7 minus 9, which is negative 2. Subtract 9 here, subtract 9 here. That will be negative 4x equal to negative 16. Okay, for both of them, we're gonna divide it by negative 4. So you find out that's a two solution, x equal to 1/2 or x equal to 4 here. After you're done, you could double check your work. Plug it back to the original equation. Okay, when x equal to 1/2, we'll plug in here. So 4 times 1/2, that will be equal to 2. 9 minus 2, that will be equal to 7. Okay, same idea for this guy. So both of them, we're gonna get the true statement. So our solution set will be 1/2 and 4. Okay, example 2. We have an absolute value of A equal to absolute value of B. So from the previous slide here, you're gonna see this. Absolute value of A equal to absolute value of B. We can write down the answer A equal to B or A equal to negative B. So first one, 3x plus 2 equal to x minus 5. Or 3x plus 2 equal to negative parenthesis x minus 5. Now we're going to solve for the x here. So here we're going to subtract x for both sides. And then we're going to subtract 2 for both sides. Divided by 2, you're going to get x equal to negative 7 over 2. Okay, this one. First, you need to distribute the negative. Okay, negative, you're going to get positive here. And then we're going to combine the 9 terms. We're going to add x for both sides, subtract 2 for both sides. You're going to get 4x equal to 3. Divided by 4. So x equal to 3 over 4. Now, check your solution. Plugging back to the original equation here to see if you're going to get the true statement. Do it by yourself, okay? You should get both of them true statement. So the solution set will be negative 7 over 2 and 3 over 4. Okay, right? These two example is talking about the absolute value with the equation. That's an equal sign. Now, example 2. We do have an absolute value inequalities. So this one, strictly less than. So that will be the case 2, right? So the x will be in between negative 10 to positive 10. Okay, this is the case 2. And then this is a 3-part equation. So we're going to add 6 for each of them. S6 here, S6 here, and S6 here. So you should get negative 4, strictly less than 4x, strictly less than 16. And then divided by 4 for each side here. So you're going to get x is in between negative 1 to 4. Okay, so this is going to be my solution set. We're going to use the parenthesis because there's a no equal sign here. Okay, one more time. This guy, absolute value of x, strictly less than k. So you know k is in between negative 10 and positive 10. And this one, absolute value of x greater than k here. So that would be this joint solution, right? So 4x minus 6 less than negative 10. And then 4x minus 6 strictly greater than 10, okay? That's an OR. Solve the equation one by one. We're gonna add 6 for both sides divided by 4. So you're gonna get x strictly less than negative 1. Same idea for this guy. Add 6 for both sides divided by 4. So the solution set will be negative infinity to negative 1 or 4 to positive infinity. Okay, right? This is going to be your case 3. This is going to be your case 2 here. Okay, this one. Think about it. This is going to be case 2 or case 3. We do have a greater than, right? So that's a disjoint solution. That would be the case 3. But before we're working on it, we need to have one absolute value on the left hand side and then one constant on the right hand side. We do have the 6 here. Okay, so before we apply the case 3, we're going to subtract 6 for both sides. Subtract 6 here, subtract 6 here. Okay, right? Make sure you do have an absolute value of x greater than or less than a constant. Then you could apply the case 2 or case 3. So this is a case 3. So we have a 5 minus xx less than or equal to negative x. Or 5 minus xx greater than or equal to x. Okay, solve the inequality. We're gonna minus 5 for both sides here. Divided by negative x. Remember, when you multiply or divide by the negative number, you need to reverse the direction of the inequality. Okay, I switch the sign here. This one do the same thing. I divide by negative 8, so I'm gonna switch the direction of the inequality. So my solution set, that will be, we're gonna write down this guy first, okay? Always look at it from the left to the right. So from negative infinity to negative 3 over 8, or 13 over 8 to positive infinity. Make sure the order does matter, okay? Okay, example 4. 7x plus 28 equal to 0. So this is going to be the case 1, right? But think about it. Can 0 be positive or negative? No, right? So it doesn't really matter when you have the absolute value of x equal to 0. We could just write it down like 7x plus 20x equal to 0. Okay, negative 0 or positive 0 is also equal to 0. So we only care about this guy. So we only write it down as a 7x plus 28 equals 0. Solve this equation. We're going to subtract 28 for both sides. Divided by 7. You're going to find out x equal to negative 4. So you could double check your work, plug in back. So negative 4 times 7, negative 28 plus 28. That will be equal to 0. So this is going to be our solution set. Okay, another one. Absolute value of 6x minus 9 strictly greater than negative 2. But think about it. The absolute value of a number is always non-negative, okay? This guy has to be positive. So positive is always strictly greater than a negative number. Okay, so this is always true. That means no matter what you put for the x, this statement will be a true statement. So our solution will be all real values, all real numbers for your x. So solution set negative infinity to positive infinity. No matter what you put for the x, you're going to get the true statement. Okay, last example. This one, absolute value of 2 minus 5x less than or equal to negative 5. Think about it. For this guy, when you take the absolute value, this is always a positive number. Is it possible that a positive number less than or equal to negative number? No, right? So that's no number whose absolute value is less than negative 5. So this statement is always false statement. No matter what you put for your x here, this number will be a positive number. And a positive number that's impossible to less than or equal to a negative number. Okay, so the solution set will be the empty set, means no solution. That's it.